Have you ever wondered what secrets lie beyond our Milky Way? The Andromeda Galaxy, our nearest galactic neighbor, is a cosmic marvel packed with mysteries and mind-blowing facts. Did you know it's on a collision course with the Milky Way, or that it contains over 1 trillion stars? Join us on this captivating journey as we unravel 10 fascinating facts about the Andromeda Galaxy and explore the universe like never before. The largest galaxy in our local group. The Andromeda Galaxy isn't just a stunning celestial object, it's also the largest galaxy in the local group, a cosmic neighborhood that includes the Milky Way and around 54 smaller galaxies. Stretching approximately 220,000 light-years in diameter, Andromeda is about twice the size of the Milky Way. Its sheer scale makes it a crucial subject for scientists studying galactic formation and evolution. Despite its massive size, Andromeda's structure is relatively familiar. It's a spiral galaxy with a bright central bulge and magnificent arms that sweep outward, filled with stars, gas, and dust. These arms are a breathtaking sight when captured in high-resolution images, revealing vibrant regions of star formation. Andromeda's immense size also means it has a significant gravitational influence. It has several satellite galaxies orbiting it, much like the Milky Way has the Magellanic Clouds. These smaller galaxies offer researchers a window into the dynamics of galactic interactions and mergers, processes that shape the cosmos over billions of years. For stargazers, Andromeda is an awe-inspiring sight. Under clear, dark skies, you can even spot it with the naked eye. Located 2.5 million light-years away, this majestic galaxy reminds us of the vastness and beauty of the universe, sparking curiosity and wonder in all who observe it. Home to over 1 trillion stars. One of the most astonishing facts about the Andromeda Galaxy is its staggering number of stars. With over 1 trillion stars, it outshines our Milky Way, which has around 200 to 400 billion stars. This enormous population makes Andromeda a treasure trove for astronomers searching for clues about the life cycles of stars and the potential for planets in distant galaxies. Within Andromeda, you'll find stars of all types, from ancient red giants to young, hot blue stars. Its dense star clusters like NGC 206 are particularly fascinating, showcasing regions teeming with newly formed stars. These clusters are prime targets for telescopes and provide a glimpse into the galaxy's stellar diversity. Andromeda's stars are distributed across its expansive disk and central bulge. Its nucleus is especially intriguing, with a supermassive black hole surrounded by a dense cluster of stars. This setup is similar to what we see in the Milky Way, offering a chance to compare and contrast galactic centers. With such a vast number of stars, the possibilities for planetary systems and perhaps even extraterrestrial life are tantalizing. While we may be light-years away from uncovering these secrets, Andromeda continues to inspire dreams of intergalactic exploration and discovery. Andromeda and the Milky Way are on a collision course. Perhaps the most dramatic fact about the Andromeda Galaxy is its eventual fate. It's on a direct collision course with the Milky Way. Traveling at a speed of about 110 kilometers per second, Andromeda will merge with our galaxy in roughly 4.5 billion years. This galactic dance is a vivid reminder of the ever-changing nature of the cosmos. When Andromeda and the Milky Way collide, it won't be a violent crash as one might imagine. Galaxies are mostly empty space, so stars and planets are unlikely to collide directly. Instead, the gravitational forces will reshape both galaxies, creating a new elliptical galaxy often referred to as Milkomeda. During this cosmic event, the night sky on Earth will transform dramatically. Andromeda will grow larger and brighter, dominating the heavens as the galaxies draw closer. The eventual merger will set off bursts of star formation as gas and dust clouds collide and compress, igniting new stars. While the collision sounds catastrophic, it's a natural part of galactic evolution. For astronomers, it's a thrilling opportunity to study these processes and gain insights into the life cycle of galaxies. For us, it's a humbling reminder of our place in an ever-evolving universe. A history of galactic cannibalism. The Andromeda Galaxy has a history as dramatic as its future. It's known for its role as a cosmic cannibal, having absorbed smaller galaxies over billions of years. This process, known as galactic cannibalism, has helped Andromeda grow to its current size and complexity. Evidence of this cosmic appetite comes from the faint streams of stars that extend outward from Andromeda's disk. These star streams are remnants of dwarf galaxies that were pulled in and torn apart by Andromeda's gravitational forces. Observations of these features have provided astronomers with a clearer picture of how galaxies grow through mergers. Andromeda's appetite isn't just limited to smaller galaxies. Its gravitational pull influences nearby systems, setting the stage for future interactions. This ability to dominate its local environment underscores its status as a powerful cosmic entity. The history of galactic cannibalism reminds us that galaxies are not static structures. They evolve and change, driven by the intricate ballet of gravity. Andromeda's story is a testament to the dynamic nature of the universe, where even the mightiest galaxies are shaped by the forces around them. A supermassive black hole at its core. At the heart of the Andromeda Galaxy lies a supermassive black hole, an enigmatic entity that exerts immense gravitational pull. Located in its nucleus, this black hole is estimated to be between 100 and 200 million times the mass of our Sun. It's surrounded by a dense cluster of stars, creating one of the most energetic regions in the galaxy. This black hole is not just a solitary entity. Evidence suggests Andromeda's core may harbor two black holes in a binary system, the remnants of a galactic merger billions of years ago. This discovery adds a layer of intrigue to Andromeda's history, offering clues about its tumultuous past. The influence of the supermassive black hole extends far beyond its immediate vicinity. It shapes the orbits of stars in the central bulge, creating a dynamic and chaotic environment. The study of Andromeda's core provides a unique opportunity to understand how these powerful objects influence galaxy formation and evolution. For astronomers, the supermassive black hole in Andromeda is like a cosmic laboratory. Observing its activity helps scientists uncover the secrets of black hole growth, galactic interactions, and the role of gravity in shaping the universe. It's a stark reminder of the power and mystery hidden within galaxies. Andromeda is blue-shifted. Unlike most galaxies, which are red-shifted as they move away from us, Andromeda is blue-shifted. This means it's moving toward the Milky Way, and its light appears compressed to shorter wavelengths. This unique characteristic is a direct result of the impending collision between the two galaxies. The blue shift is a rare phenomenon in astronomy, as the universe is generally expanding. Andromeda's motion defies this trend because the gravitational pull between it and the Milky Way is stronger than the universe's expansion in our local group of galaxies. This unusual movement offers astronomers a real-time view of galactic dynamics on a grand scale. Studying Andromeda's blue shift allows scientists to measure its speed and trajectory with remarkable precision. It also provides a glimpse into the processes that govern galaxy interactions, helping researchers understand the intricate gravitational ballet that defines the cosmos. For us, the blue-shifted light is a cosmic signal of Andromeda's approach. It's a reminder that even in the vastness of space, galaxies are in constant motion, influenced by unseen forces that connect them across unimaginable distances. A rich history of star formation. The Andromeda Galaxy boasts an extraordinary history of star formation, spanning billions of years. Its expansive disk is filled with regions where stars are born, fueled by vast reservoirs of gas and dust. These stellar nurseries create breathtaking phenomena that can be observed with advanced telescopes. One of the most active areas in Andromeda is its spiral arms, where star-forming regions shine brightly. These arms are dotted with hot young stars that illuminate their surroundings, creating stunning visual contrasts against the dark cosmic backdrop. Andromeda's history isn't just about new stars, it's also a story of cycles and change. Some regions show evidence of older stars that have exhausted their fuel, leaving behind white dwarfs, neutron stars, and even black holes. This diversity offers a comprehensive view of stellar evolution within a single galaxy. The study of star formation in Andromeda provides valuable insights into our own galaxy's past. By comparing the two, astronomers can piece together the puzzle of how galaxies evolve over time, creating the complex and beautiful structures we see today. A spiral with a halo. The Andromeda Galaxy isn't just its spiral disk, it's surrounded by an enormous halo of gas and stars that extends far beyond its visible edges. This halo is so vast that it spans over 1 million light-years, making it larger than the galaxy itself. This halo is composed of hot gas, old stars, and remnants of galaxies Andromeda has absorbed. It acts as a cosmic shield, interacting with Andromeda's surroundings and playing a crucial role in its evolution. Observing this halo provides insights into how galaxies acquire and lose mass over time. The halo also contains globular clusters, dense groups of ancient stars that orbit the galaxy's core. These clusters are some of the oldest objects in the universe, dating back to the early days of galactic formation. Their presence offers a glimpse into the conditions that existed when the universe was young. For astronomers, the halo of Andromeda is like a cosmic time capsule. It holds clues about the galaxy's past interactions, its growth, and the forces that shaped it. It's a reminder that galaxies are not isolated entities but are deeply connected to the universe around them. Bright Cepheid variables in Andromeda. One of the most fascinating aspects of the Andromeda Galaxy is its abundance of Cepheid variable stars. These stars are known for their consistent brightness fluctuations, which make them invaluable tools for measuring cosmic distances. The discovery of Cepheid variables in Andromeda was a groundbreaking moment in astronomy. In the 1920s, Edwin Hubble used these stars to calculate the distance to Andromeda, proving for the first time that it lay outside the Milky Way. This revelation transformed our understanding of the universe, showing that it was far larger and more complex than previously imagined. Today, Cepheid variables continue to play a vital role in astronomy. Their predictable patterns of light help scientists refine distance measurements and study the expansion of the universe. Andromeda's Cepheids remain a key resource for calibrating cosmic scales. These stars are more than just tools for astronomers. They're a testament to the power of observation and the ingenuity of scientists who unlock the universe's secrets. They remind us that even the smallest flickers of light can lead to the greatest discoveries. The Andromeda Galaxy's two cores. Andromeda's nucleus is a mystery that has fascinated astronomers for decades. Unlike most galaxies, it appears to have two distinct cores. These cores are likely the result of a galactic merger that took place billions of years ago, leaving behind a dynamic and complex central region. The two cores consist of densely packed stars orbiting a shared gravitational center. One core is thought to be the original nucleus of Andromeda, while the other is likely the remnant of a smaller galaxy that was absorbed during a merger. This unique structure offers a rare glimpse into the aftermath of galactic collisions. Studying these cores has revealed intriguing details about Andromeda's past. Their interactions show how galaxies grow and evolve through mergers, reshaping themselves over time. These findings also help scientists understand the role of central black holes in shaping galactic nuclei. For stargazers and scientists alike, Andromeda's double core is a captivating feature. It's a reminder that galaxies are constantly changing, shaped by the cosmic forces that govern the universe. It's a story of resilience and transformation on an intergalactic scale. That wraps up our journey through the Andromeda Galaxy, a breathtaking marvel of the cosmos filled with incredible secrets and discoveries. From its massive size to its dynamic future, Andromeda inspires wonder and curiosity. If you enjoyed this cosmic adventure, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated on our latest videos. Until next time, keep exploring the universe with us.